The James Webb Telescope has made a groundbreaking discovery suggesting another universe beyond our own. Recent Webb data from the deepest regions of the early universe implies that our universe may have merged with another in its infancy. Scientists have identified strange ancient galaxies in the early universe that challenge our current theories. This new evidence indicates that the early universe we observe is fundamentally different from the universe we know today. Prepare to be amazed. The James Webb Telescope has delved deeper into the early universe than ever before, uncovering sights previously unimaginable. Alongside these stunning deep space views, the telescope has detected peculiar phenomena. Its latest findings have left astronomers worldwide in awe, reshaping our understanding of the cosmos. The universe has always fascinated us with its vastness. We often ponder if it has an edge or if it stretches infinitely. Observations with powerful telescopes indicate that our universe began about 13.8 billion years ago. Based on this, scientists created a standard cosmic model to explain its evolution. However, recent data from the James Webb Space Telescope challenges these long-standing theories. This telescope, probing deeper into the early universe than ever before, suggests our understanding may need revision. Traditionally, we've thought the universe had a definite beginning and has been expanding since. Now, some scientists are exploring the possibility that the universe might not have begun in the conventional sense, or that the early universe was vastly different from what we know today. At the 2024 International Space Science Institute Breakthrough Workshop in Bern, Switzerland, scientists presented findings from the Webb telescope. Their work appears in the new paper titled The First Billion Years According to James Webb Telescope. Scientists have closely studied the first billion years after the Big Bang, a period when galaxies were young, stars and black holes were forming and growing. Observing these early galaxies requires the most advanced telescopes. The Hubble Space Telescope could only observe up to a redshift of 11. The Webb telescope has pushed this limit to z equals 14, just 300 million years after the Big Bang. Moreover, astronomers have detected carbon in a galaxy observed 350 million years post-Big Bang, suggesting that conditions for life may have been present almost from the start. The early presence of oxygen in this galaxy is surprising and implies that multiple generations of very massive stars had already lived and died before we observed it. All these observations reveal that JADES GSZ14 does not align with the galaxy types predicted by theoretical models and simulations for the very early universe. With this data, scientists now claim that the James Webb Telescope will soon observe galaxies from a time when the universe was extremely young, at a redshift of 20. This means looking back to when the universe was only a few 100 million years old. However, they worry that if the telescope finds even more distant galaxies, it could challenge our understanding of how galaxies form. According to the standard cosmological model, there is a limit to our universe beyond which we cannot see, known as the Dark Age. Following the Big Bang, the universe entered a period known as the Dark Ages. During this time, it was filled with neutral hydrogen gas, and without stars or galaxies to emit light, it was opaque and dark. To date, our knowledge of the universe beyond the Dark Ages is purely theoretical. No one truly knows what lies beyond. Surprisingly, new images from the James Webb Telescope have shown galaxies existing even before the Dark Ages. This discovery baffles scientists, as it's unclear how these galaxies formed so early. Even more puzzling is that these ancient galaxies appear vastly different from those we see in the early universe. These findings pose a profound question. Could we be observing an entirely different universe? Why are we discovering such giant and mature galaxies as we peer deeper into space? According to our physics, We should see smaller, younger galaxies in the early universe and expect no galaxies or stars beyond a certain distance. Yet, as the Webb telescope explores further back, it continues to uncover more massive galaxies, suggesting we might be viewing a universe with different physical laws. It's not just the massive galaxies beyond the dark ages that challenge our theories. Other anomalies also defy expectations. Recent research has introduced a surprising twist to our understanding of the universe's early days. The fundamental laws of physics, which work well for the nearby universe, might have been slightly different in the past. A study in the Journal of Cosmology and Astroparticle Physics proposes that gravity could have been about 1% weaker on very large scales in the early universe. This discovery emerged from analyzing data from the cosmic microwave background, CMB, the faint radiation left from the Big Bang. The CMB is essential for understanding the universe's early stages, including the formation of the first galaxies and events right after the Big Bang. However, their model initially did not match the observations of the distant universe. When they adjusted Einstein's theory to account for 1% weaker gravity, the model fit the data more accurately. This minor adjustment suggests that Einstein's theory might need reconsideration regarding the early universe. Another major issue in cosmology is that recent observations from the James Webb Telescope reveal the universe is not expanding uniformly. Different measurement methods yield varying values for the rate of expansion. Astronomers have confirmed the accuracy of these methods. There is no measurement error. This discrepancy indicates that the universe's expansion rate varies in different regions, and the cosmological constant, or dark energy, which drives this expansion, is not truly constant. It appears to have different values in different parts of the universe. All these discoveries now suggest that the deeper we probe into the early universe, the more our theories fall short. Various theories have been proposed to explain this asymmetry. One idea is that our universe collided with another during its rapid expansion. According to the multiverse hypothesis, our universe could have emerged near another universe, and as it expanded, it might have intersected with this neighboring universe. This collision could explain why physical laws aren't uniform across our universe, with different regions, like the southern and northern parts, possibly governed by different sets of laws. This hypothesis might account for the presence of strange, massive galaxies just a few million years after the Big Bang and the observed differences in the universe's structure in various directions. The discrepancies between our theories and observations of the early universe are unveiling many hidden mysteries. New images from the James Webb Telescope are offering fresh possible explanations about the nature of our universe. We might either be missing a crucial piece of our current understanding or find that the early universe is beyond our grasp. That's it for today. I hope you enjoyed the video. Share your thoughts on these recent discoveries in the comments. Thanks.